Good morning, students. Welcome to physics video class. In today's session, we are going to discuss two important concepts in our unit 6 gravitation. First one is escape speed and second one is energy of an orbiting satellite. First, you see the animated video related to the escape speed. Afterwards, we derive the derivation and find the what is the value for the escape speed of the earth. Now watch the video carefully.
Escape velocity. Imagine a cannon shooting upwards in the sky. You will notice that it goes up to a certain height and falls. Let's try again. One more time, but with a lot more power. If somehow we can manage to shoot the cannon with very high velocity so that the body escapes Earth's gravity, then this velocity is known as escape velocity. Or in other words, the minimum velocity which a body must have in order to escape the gravitational attraction potential of a planet is known as escape velocity. Consider a planet like Earth. Escape velocity is different for different planets depending upon the gravitational pull, which is the function of mass of the planet and its radius. Let's assume that we have to launch a rocket into space from any planet. Consider the mass of the planet is equal to m. Radius of the planet is equal to r. Mass of the rocket is equal to small m. Potential energy of rocket on surface of planet is minus g m upon r. Here, the negative sign implies that the force is attractive in nature. Also, potential energy of the system is always negative. At the time of the rocket launch, the kinetic energy on the rocket is equal to half mv square. Let's call this equation 2. Comparing the two equations gives us the minimum velocity required to overcome the potential energy of the planet. That is, escape velocity is equal to square root of 2 gm by r. From this relation, we can note that the escape velocity is independent of the mass of the rocket. It only depends on the mass and the radius of the planet. Therefore, a rocket having minimum velocity equal to or greater than escape velocity, then it will follow a curved path and will escape the gravitational pull of Earth. However, if the rocket is launched with the velocity less than escape velocity, then it will fall back on Earth due to gravity.
Students, we continue our derivation part. So this is very important 5-mark question. In this lesson, we have to give the first preference to this question. Now, consider where m is the mass of the object and vi represents the initial speed of the object and me represents the mass of the earth and re represents the radius of the earth and e represents the total energy of the object. Now, according to the law of conservation of energy, we studied in our 4th lesson. So the initial energy is equal to the final energy. So consider this is equation number 1. So first we are going to find what is the initial energy. Then we are going to find the final energy and substitute in this equation number 1. Let me see the initial energy. To calculate the initial energy, we have to know the sum of the kinetic energy plus sum of the initial potential energy. So this is equation number 2. So we are going to find what is the initial kinetic energy and what is the initial potential energy. Since we know the initial kinetic energy equal to half m vi square, because the velocity is initial, so I represented vi square, and initial potential energy is equal to minus capital G capital M capital MA by RE. And substitute in the above equation, so we get initial energy EA equal to of mvi square minus capital G M ME divided by RE. So this is equation number 3. So this equation 3 represents the initial total energy of the object. Now coming to calculate the EF, that is final energy of the speed. Since now the object is reached a certain height from the above the earth surface, we don't know what is the height, so therefore the height will be considered as a infinity. So according to the potential energy we know mgh, so the h will be equal to infinity, so therefore the value should be 0, that is the potential energy becomes 0. Also, if the potential energy is 0, what about the kinetic energy? So if the object is don't know the distance from the earth surface, we can't find what is the kinetic energy takes place, then the kinetic energy of the body also become 0. Therefore, according to the law of conservation of energy, the final energy EF equal to final kinetic energy plus final potential energy. Therefore, the value should be equal to 0. Therefore, EF equal to 0. This is equation number 5. Now, substitute equation 3 and equation 5 in equation number 1. So, we get of mvi square minus g m me divided by re equal to 0. Now, move the minus sign in the opposite term. We get of mvi square equal to capital G m me by re. This is equation number 6. Now, according to the definition of the escape speed, so the minimum speed will be required by an object to escape from the Earth's gravitational field. Okay, so therefore here the initial velocity vi is changed as ve, that is escape velocity. So vi is changed as ve and substitute in the equation number 6. So we get of mve square equal to capital G me by re. Since we need the what is the escape speed of the earth, so therefore we keep velocity in one side and other terms will move in the opposite side. Therefore v square equal to capital G me by re into 2 by m. Now cancel the common terms in right hand side. So we get v square equal to 2g me by re. Now in this equation also we can directly find the what is the escape speed formula for the earth, but we are going to modify this above equation. So I am going to multiply and divided by re in the above equation in the right hand side. So we get v square equal to 2gme into re divided by re square. So already in denominator one re term will be there and now it becomes re square. Now since we know the value for capital G me divided by re square is what? Acceleration due to gravity small g, and substitute in the above equation. So we get v square equal to 2g re. Now we need only ve, that is the escape speed. So send the square in the opposite side, we get square root of 2g re. This is equation number 7. So this equation 7 represents the what is the escape velocity of the object. Using this formula we are going to find the value of escape speed of the earth. Now since we know the value of small g equal to 9.8 meter per second square and the radius of the earth re equal to 6400 kilometer, and substitute in the equation number 7. So we get ve equal to square root of 2 into 9.8 into 6400. So finally we get approximately the escape speed of the earth is 11.2 kilometer per second. So this is very important 5-mark question. So please go through well. Students, next we are going to discuss about energy of an orbiting satellite. Now the satellite is revolving around the earth in its orbit. What is the energy required to rotate in its orbit? We are going to find the derivation. Now The satellite is placed from the above the earth surface at the certain distance is represented as h. So to calculate the total energy of the satellite, so we have to calculate the sum of its kinetic energy and the sum of its gravitational potential energy. Students, see this diagram. So this diagram represents the satellite is revolving around the earth in its orbit at a certain distance from the above the earth surface. So in this orbiting satellite, we are going to find the what is the energy. So taking the kinetic energy and the gravitational potential energy. First we are going to calculate the what is the potential energy of the satellite. Since we know the formula where U equal to minus G ms me divided by R. So what is R represent? So R represents the total distance from the satellite to the center of the earth. Therefore R equal to Re plus H, and substitute in the above equation. So we get U equal to minus G ms me by Re plus H. This is equation number 1. Since where ms is the mass of the satellite and me is the mass of the earth, and capital G represents the universal gravitational constant, and Re represents the radius of the earth, and H represents the height of the satellite from the above surface. Then we are going to calculate the what is the kinetic energy of the satellite. So the kinetic energy Ke equal to of ms v square. So here v represents the velocity of the satellite, that is the orbital velocity of the satellite. This is equation number 2. In last class we studied the what is the orbital velocity formula. So v is equal to square root of G me by Re plus H. This is equation number 3. Now substitute the v value in the equation number 2. So we get kinetic energy equal to of ms into square root of G me divided by Re plus H whole square. Now the square and the root become cancel. Therefore the kinetic energy equal to of G me into ms divided by Re plus H. This is equation number 4. That is, this equation 4 represents the kinetic energy of the satellite from the above the earth surface. Now according to the total energy, we now have to add the sum of the kinetic energy and potential gravitational potential energy. Therefore E equal to of G me into ms divided by Re plus H plus minus of G ms me by Re plus H. Now see, rearranging the right hand side, so we get of G me into ms divided by Re plus H minus G ms me by Re plus H. Now subtracting the right hand side, so simply you can take, so 1 by 2 minus 1, so we get what? Minus 1 by 2, isn't it? Likewise, now the value is half of the value in the kinetic energy and the full value in the potential energy. So we get the value E equal to minus G ms me by 2 Re plus H. This is equation number 5. Here the negative sign represents the energy implies in the satellite which will be in the boundary of the earth. So that's why it is never escape from the earth surface, only it will be revolving in its orbit. That's why we are using the negative sign. Now coming to end of this session. In today's session we discussed the two important concepts in our lesson: gravitation. One is escape speed and another one is what is the energy of the orbiting satellite. I hope you all understand clearly. See you in the next video class. Thank you.